Hello, very good morning. Let's Today 17th of November and this is what we have today as a daily. We'll try to solve this is one of the trickier problem I have encountered so well, and the only reason I'm saying this is of negative numbers, as I will show you that with positive numbers it is very easy to find any shortest subarray with some at least k, but whenever there's a negative number it is going to cause some problem. So as you can know what I'm talking about, let's read the question. So it says that given an array nums and an integer k, so this and this, you have to return the length of the shortest non-empty subarray of nums such that the sum is let's define the subarray I to j. So sum of this should be at least k, and we have to report the length of j minus I. So like the the hardest thing in this problem is that it contains negative number. So if we have an array of just positive numbers, let's say 4, 2, 1, and 3, and 7, and we want k as 7, for example, then what we can just do is we'll insert some put a pointer here, like put two pointers here. We if L is equal to 0, R is equal to 0, and we'll move R such that the sum, let's say while is and R is in the bound and is the length of this array, and sum is basically AR of R. So now our sum would be here is 4, then 2, then 1. This point the sum is at least 7, right? Then we'll try to decrement if we can such that this subarray holds greater than 7. Now we can't, right? As we'll subtract 4, it will become 3. So we can't. But this is it gives me 10, right? Like adding 3 with 10. Now we can subtract 4 to make this array greater, like this sum of subarray. Sorry, this subarray so that its sum is greater than equal to 7. No, we can't. Cannot subtract this because after removing this it will give me some 3 plus 1 plus 2, that is 6. Okay, now it comes to 17 if we add this. Now can we remove this? Yes. 17 minus 4 is 13, which is our can be an answer. So we have this subarray which has sum greater than equal to 7. Now can we subtract 2? Yes, it is also greater than 7. Can we subtract 1? Yes, it is also greater than 7. Can we subtract 3? Yes, it is also greater than 7. So the least we can get is 1, like size of 1. The problem with negative numbers is that the sum won't be monotonic. It won't always be increasing. It will be increasing, then decrease, then increase, and then decrease, or something like that. So here we have to maintain that what is the monotonicity of sum along regions. Now what does that means? That if I'm having this example, let's so if we're having this example, so if we like to like sum this all, this minus 1, initially the sum is 0, now this is minus 3, this 5, this is 2, this is minus 2, this is minus. So you can see from point it decreases, it decreases, it increases, it decreases, it decreases, and it decreases. So here, if you're running two pointers, you won't be able to conclude whether to go forward or stop, or whether this answer lies in this bracket, but I'm not having in some grid, because when we are putting this condition, very good, like yeah, okay, like if while sum minus a of L, right? This pointer is greater than k, then AR of L, sum minus AR of L. Basically, standing here, we'll just decrement this, like this, and this, so that you can have an idea whether my subarray is having greater sum or not. Here you cannot do that, because whenever you try to subtract this thing, you will, let's tell you an example. Like make it 8, make it 1. Now 2, 3, and 1, for example. And k should be 6. Yes. So this is 8, this is 7, this is 9, and this is this is 12, this is 30. So yes, this is greater than equal to 6. We have answer 1. This is also greater than 6, but our answer will remain 1, or make it 4, I guess, or make it 9, yes. So we have no answer till now. This is 7, this is 9. But now, if I'm standing here, like, if I had to remove this, it will still here. What is the sum? 9. What is 9 minus 8 is what? 1. So this can't be an answer. The answer would be still 3. Then if we standing from here, if we'll subtract this, so what would the answer? 3 plus 2 minus 1, that is 4. 4 plus 8 is 12, but removing plus 2 plus 4. This can't be the answer. Then I'll add 13, right? If I'm subtracting 13 minus 8 here, it is giving me 5. So obviously I cannot go there, right? Like I cannot move forward as I was moving forward here. But what I can see is there is an answer that lies like next to ahead of this index, but has a sum of 9. This could be an answer, but as there is no monotonicity, we can't go forward because of this negative number. So what we're trying to do is to use some concepts or some like tricks to solve this tricky problem. So we will use two things. One is prefix sum and a deck. If we know what is a queue, it's queue is basically, sorry, queue is basically this. You push here and you pop here. But with deck you can do, you have a container where you can push and pop, push and pop. That is, you can push in the front and push in back also. So this is what it like another feature that deck provides over queue. And what is prefix sum? If you're not familiar with prefix sum, you can ask for a detailed video, but prefix sum is basically, let's say, an array, and if I need a sum of this, then I'll just work like accumulate this like 1, 2, 3, 4 will be written as 1, 3, 6, and so that whenever I need a sum of this subarray, like let's say I and j, I can subtract 10 minus 1, prefix of j minus prefix of I minus 1 would be the sum of subarray I to j. So this is a technique. I'll explain you later like how to code this and all. And with the help of deck, we'll try to solve it. Now, how deck would be crucial here? What is the importance of deck and actually why deck? Like why deck is the most optimal data structure? I guess this can be solved with two pointers, but using a deck gives you very efficiency on storing what you're doing. So let's take this example again. There was that example, negative numbers. Yeah. So first we'll create a prefix array. So let's put a zero here so that I know whenever I want to subtract like I minus one, I'll always have 0 to like not worry about any runtime error or out of bound. So 0 plus minus 1 gives me minus 1. This is minus 3. I did this initially here, but I'm doing this again. 5 minus 2, side 2 minus 2 and then minus. So this will be our prefix array. Now, as I told you earlier, the whole game is about monotonicity of the like the sum of the arrays. Then we only focus on that. So this is what we have in here. Okay, 0. Is this less than 0? Yes. So can it give me like I would say greater sum if I am decreasing by adding something? Then it can never increase me. This is like some basic logical uh, I would say equations you can make that. So I won't consider this, right? But I am decreasing here, so there must be negative adding to this. So the prefix sum is decreasing. So this index doesn't matter to me. Like I have no I would say like relation or any betterment storing this. So I'll just remove this. Now I'm here. It's still decreasing, still decreasing. Okay, I'm like sorry. I have to store indices like indexing storing indices are better. So 0, 1, 2. I'll remove that. I'll remove that. Now I have to. But now I'm increasing, right? So let's check if I have increasing. Now let's check. Is prefix of current like this is my current, and this is what I have the recent one. The prefix of 3 minus prefix of 2 is which is 5 minus 3 is equal to 8, which is our element, which is greater than 7. So we got an answer, right? And what is the difference between these two indices? That is 3 minus 2, 1. Now it's decreasing, so I'll remove this. And every time I'm removing, I'm just like not holding it here, but I'm holding current one so that to know where am I right now. It's decreasing, it's decreasing, it's decreasing. So it's like 3, 4, 5. It all will get removed. The only time it increasing will check that can we generate a sum greater than like k that we had earlier. I'll explain one of the test cases that we have in the question or like I wrote it somewhere. Wait, for this one I was trying to say that there exists a sequence, but yeah, 8 minus 1, 2, 3, 4. So 8 minus 1, 2, 3, and 4. And we had k is equal to 9. So write a prefix for this one. Prefix on 1, 7, 9, 12, and this is 16, right? So initially we have 0 and this is increasing, right? So but we have can check that 8 minus 0 is obviously no, this is not greater than 9, so our answer is still nothing. Now this is decreasing, then I'll remove this, now I'll use this. Now this is increasing. So does this one gives me a greater than 9? No, because 9 minus 8 is like 1. So this like now I have this and this is 3, now I'm here 12. Now this is increasing, right? So I won't remove this, I'll store this. Now 12 minus 8 gives me greater than 9? No. I'll store this in x. Now I'm here. Now 6. Wait, no, I should have removed this. Yes, I should have removed this once because this is decreasing, right? So I'll remove this. So there will be 2, 3, and 4. Sorry. So 16. That's what I'm thinking of why I'm not having an answer. So this is 16, but 16 minus 2 makes 7. Plus gives me 9. This is what we are subarray array. Now you must be wondering whether I'm subtracting from here, then why I am considering this, because remember when I wrote that sum of the array of ij is j minus I minus 1. So the array of I is j minus I minus 1. This is what we are doing. And this is fairly easy to implement, just only trickier to understand. And I love these kind of problem. I actually submitted this right now, but I'll try to code it again. So first we'll extract the space of the array. We'll create a make sure to make it long because you know 1 if 5 exceed the integer bound, then I'll make a def or and check on the maximum 1 minus n plus 1. Sorry, let me the right pointer from 0 that goes to the end of it. I forgot to build the prefix array. This should work. Now, what I have to do first is first whether it is increasing or not. So I'll check while dict is not empty, and then prefix is right is less than equal to eq prefix of decay back, then we will pop this out. Now what we'll do, if this condition satisfies that this is increasing, then we'll check whether these have a difference of t or not. So first check whether they are empty or not, and if prefix of right is prefix of front is less than equal to k, now it is enough for right minus eq of front, and we'll pop that out as they are used. And if these both are not satisfying or either one is satisfying, we'll always update the current one. If it's still 1 plus 1 will answer like minus 1, then other is should be. Passes and it is quite fast and efficient. This has a like time complexity of O(n) because the DQ has like O(n) push and pop, and I'm using O(n) of space for prefix array, and that is like one pass linear solution, so it should work. If you have any doubts, feedbacks, problem, you can drop them in comments. Thank you.